you very much. Glad to be here. For me, this is a very exciting opportunity because a panelist of people in chaos, our leaders in chaos engineering and security chaos engineering, I don't think has ever been done before. So we're going to see some answers we might not have ever seen. So I think we're going to get some good feedback and some good lessons learned out of this. So before we get started, I'd like to have everyone, our panelists, to go around and introduce themselves. Christina, if we could start with you, go to Courtney, Kelly, and then David.
Sure. So hi, everyone. My name is Christina Yakomin. I'm currently the technical lead for site reliability engineering at Vanguard, but I spent the past 1.5 to 2 years working on our chaos and resilience engineering team. So I'm excited to talk to you today about how we do chaos at Vanguard.
Hi, I'm Courtney. Good morning. Thanks for joining us, everyone. I am a researcher at Verica with Aaron. And I am focused a lot on sort of the socio-technical aspects of complex systems, chaos engineering, incidents, and all of those things that you all probably care quite a bit about. Trying to collect more data on that in the industry. So I'm very excited to chat with you all today.
I'm Kelly Shortridge. I am a co-author of the Security Chaos Engineering ebook published by O'Reilly, along with the esteemed moderator, Aaron, who is my co-author on that. Most recently, I was VP of Product Management and Product Strategy at Capsulate, which is a Linux monitoring detection company. And currently, I'm a free agent, but will be starting as a senior principal in product technology at a cloud computing company later this year.
I'm David Lavezzo. I work for Capital One as a distinguished engineer with a focus on security chaos engineering.
And David was also part of the O'Reilly Security Chaos Engineering report. He wrote the case study for Capital One. So
yes.
Great. Well, great. Let's get right into some questions. Just keep in mind for the folks listening in, and we'd love to hear questions from the audience. We're going to start off with a couple questions of our own, but we'd love to field questions as you have them. So I'm going to start off with sort of a good starting question, which would be, and if panelists feel free to chime in as you have a response. But what do you all see as the biggest challenges in your organization in adopting chaos engineering or security chaos engineering?
So I can speak for Vanguard, and I'm sure David will actually probably have quite a bit to talk about here as well, coming from Capital One, that working in the financial industry, there is both a lot of resistance to change internally, as well as a lot of barriers to change due to how highly regulated the industry is. So anytime we are enacting change, not to mention how large we are as an organization, we need to do so really intentionally and carefully. So chaos engineering was no exception to that. And when you start throwing around the word chaos, you start to raise a lot of eyebrows. So pairing chaos with resilience engineering and emphasizing how controlled chaos can make us more resilient helped us to combat some of the stereotypes and initial first impressions that people got when they first heard about it.
And for me, it took a little while because my background, I was originally hired to evaluate vendor products. So I leveraged that into, it's like, well, if we're spending this much time looking at this, maybe we should look at what we already have. Maybe what we already have is adequate. So I took the same principles for assessing vendor tools and brought that into everything. It's like, well, we spend a lot of money. There's a lot of resources, a lot of effort and time. Does our stuff work the way we think it does? So like some of the challenge, it's a lot of data. It's a lot of data. I had no idea there was so much data to review and so many results. And then being the one discovering problems, guess who gets to go in and help fix them? Right here. So that was a lot of unexpected things. And giving the message that we don't generate the chaos. The chaos is just everyday business as usual work. No one's going out of their way to make things crazy. That's just how business works when you sprints everyday work.
Yeah, that's definitely something that I wouldn't have expected at the onset either. We have a question coming from the audience here, and from Kevin Hendris wants to know what were some of the first steps that you recommend taking when starting a chaos engineering program at a company? I mean, once you have management buy-in, I guess maybe for this is for anyone, and for the previous question too, if you didn't answer that, to chime in on that. But I think this is sort of a zeroing in on the previous question. What is management buy-in? Probably is that important first steps? What other first steps are key to I guess getting to the point where you're generating value in this, or well, I'll leave it there.
So for me, I had to generate the buy-in myself. And so I did that from taking, I think, top 10 critical alerts and just checking them. Does it fire as we expect them to fire? It's like, if it's yes, cool. Well, how long does it take? So starting to measure time to detect, time to respond, all of that thing. So I was doing a lot of that background to generate the buy-in needed to actually take those first steps. So the first steps were also the buy-in period for me.
I think very similarly. One of the things that I think we recommend actually in the ebook is like starting small and thinking really carefully about what initial experiments you want to conduct. I think like starting with just like verifying that the alerts you expect to fire actually fire is like a fantastic way to start out. And certainly in general, like when you think about, with experiments, like you have to have hypotheses. So what are the highest value kind of like hypotheses to your business? It could be just like making sure that you're like any alerts that are supposed to be generated by your logging pipeline are being generated, like whatever the highest kind of like priority, like P0 sort of alert would be, like that's a great place to start because it really helps demonstrate that business value. And I think certainly on the security side, as I talk about, I feel like all the time, like security teams and programs aren't necessarily always aligned to business value. So if you can show like, hey, like we're really thinking about like what's the business priority, what would constitute kind of like a high impact, like material in finance terms, sort of incident, like that's going to be a much more powerful way to gain buy-in than just like treating it in kind of like one of the misconceptions about chaos engineering. You're just like YOLOing around in prod, like it's never going to get buy-in, right? Like you have to start small with like carefully crafted experiments that are like very focused on business value.
I was going to chime in on that too, on what Kelly said, which is, and echo what David said, which is you're sort of validating things you know will work. And I wanted to just underscore that and to make sure that you're not validating that broken things are broken. Like if you know stuff's broken, fix it. Like that, because that's not going to convince people that you should do this, right? So like really focusing on those kind of positive things and demonstrating that really and really small. Like I think you say this in the book too, but like you can run little game days that don't have to be a large, cross-organization kind of effort. And it can be a really small thing that one team, with one small service or something can do. And then you're getting not just management buy-in, but to also echo what David said, the buy-in of the people who are going to basically be on the hook to fix things when you find them. So I think that's also really key is the team level, sort of alignment to respond to whatever they do find when you do start finding, sort of unexpected things as well. But you, like Kelly said, starting really small and with high impact things is a really great place to be.
Right. Oh, so we have another question that came in here. This is a question that it's for me, I find it challenging to sort of address it just because we all, chaos engineering is still somewhat of a very nascent kind of field. But like it's, so you have people have experience at different companies. Me starting at a large company where I had it, how does it scale to like a small startup company? Like if I'm at a startup, should I be doing this? If I'm at a Fortune 10 bank, should I be doing this? Like who should be doing this? Why? Right? And what are some reasons?
It's an interesting question because I think of the early days of chaos engineering at Vanguard being such a large enterprise and receiving pushback that that's the kind of thing that happens at small tech startups that doesn't happen in large enterprises. So it's almost the flip side of the coin there. But I think that honestly, the organizational size, the operational scale is not as relevant to the efficacy of chaos engineering as the operational maturity of the environment. So I think there are some prerequisites to successful chaos engineering that Courtney started to talk about. You need to have an idea that you have a relatively stable system. If things are broken, don't start making them worse. You need a good observability platform, but all of those things can be true in an organization of any size, from a very small startup all the way to a very large enterprise.
Yeah, this is one of my favorite myths of chaos engineering, actually, that you have to be like Netflix, sort of scale or maturity to enable, to be able to do this. And the fact of the matter is Netflix got there because, and I think I can say this, their system sucked. Like they were going down all the time. And the reason that team decided to start experimenting with this stuff was they were trying to figure out like how to fix it. So the sort of hidden story in there is that the sooner you start, the quicker you'll be able to get to that kind of maturity and scale. And this is the one thing I actually have some data on so far, because I went out and talked to a bunch of folks who are interested in starting with chaos engineering, and they are across every size of organization you can imagine, from like a 6-person startup up to tens of thousands of people at the organization. And some of them are, in terms of like even their operational maturity with running technologies like Kubernetes or Kafka, they're not super experienced with those things. And they're realizing that the better way to get experienced with those and to understand how those systems are going to work as they implement them in their organizations is to be able to start having that kind of a chaos engineering platform. And they're understanding those systems boundaries better as they scale. So I really think that the mentality being that you can start it as early as possible is like, you think about implementing your monitoring and getting that stuff in place, and there you go. You're on your way to, to be able to start implementing some of those small scale chaos experiments.
So so you kind of, Courtney, you alluded to a follow-up question I have on, let's see. I feel like chaos engineering for a lot of people, it sounds like so provocative. It sounds so advanced. It sounds so like, gosh, I can't even do the DevOps. Like we can't get testing right. Like we can't even, we got all these other problems. Like, why does chaos engineering, like, well, what's this provocative thing? Why should I be doing it? Right. I feel like it's because it has this stigma to it. And I think part of it's like the way it's been marketed and sold, and as breaking things in production, and a Netflix, Facebook, Apple, Netflix, Google, Amazon kind of thing. So Courtney, I love you talked about, I think the presentation you gave, I think might have been another GOTO event. You talked about the prerequisites to chaos. You had some great myths and misconceptions. Nora Jones also has her traps of chaos. And there's just, I feel like we're like accumulating all these like misconceptions because we created a stigma around it, like that it's a hard thing to do. So I'd like each one of you to go around. If you have your favorite myth or misconception about chaos engineering, I'd like to hear hear you dispel one if you can.
I can definitely chime in on the security side, which is that, security chaos engineering, I guess, ironically or not ironically, I'm not sure which it is, like, is too experimental. It's like too new wave, basically, right? My thing is, like, we've been doing traditional security for at least 2 decades, and this is what we have to show for it. So why aren't you thinking about experimenting with something new, right? Especially something that's like very explicitly outcome driven. So I think there's this perception that like security chaos engineering specifically like isn't businessy, and it's like alternative or whatever else. But I would argue, if anything, it's far more business oriented than traditional security, because it's very much, again, like focused on how do you prioritize things that are going to have business impact? How do you make sure your systems are resilient for the things that matter to your business, like downtime? For a lot of companies, like it's very much focused on like the business sort of outcomes and making sure that your systems can handle anything that goes wrong very gracefully, which is very different from traditional security, which feels very more, to borrow from B. Hughes, who was on a panel I did recently about like textbook perfect security, right? This is the real world. Like security chaos engineering is like, this is the real world. It's kind of like rough and ugly, but we're going to survive it. For traditional security is like, how do we like artificially create this perfect world where nothing can go wrong because we block everything? And that's just a bunch of baloney, right? So I think that's my biggest myth, is that security chaos engineering is like too like new and alternative and unpolished, where I would argue actually it's far more like businessy than the way we've been doing things.
Extremely practical, in my opinion. But
Yeah, I agree on that whole thing where you know what your security program is supposed to be. We know that you design it with defense in depth, but you don't actually know and don't really historically make sure every layer you see what you're supposed to see. If it's supposed to be blocked, where is it supposed to be blocked? What program of yours, what tooling is providing the most return on investment? What's the biggest value? And I agree. I was looking up the OWASP top 10 for the last 20 years, and really nothing has changed. So we have to do something differently.
The other thing I wanted, there's a lot of terminology, and I think, Aaron referred to this, and, some people are calling these things like attacks, and it's chaos, and it definitely doesn't sound good. And if you peel back all of that stuff and get down to what you're really doing, and Kelly was really saying this, it's basic experimentation. You may have learned about this in high school chemistry or college something. I mean, it's like you have a hypothesis about something, you introduce a change, you measure what happened, and you either confirm or you deny your hypothesis. And that's not new or fancy at all. And sometimes I struggle with this analogy. I'm not sure it's the right one yet, but I right now we're talking a lot about clinical trials and vaccines and things like that. And clinical trials are very much in a way what we're doing with software here, right? We're testing what happens, we're validating or disproving, our hypotheses. And so I'm not saying that's how you're going to necessarily sell it to people within the organization, but when you break it down to being something like that, it doesn't feel so mystical or so fancy or new or so dangerous. I think it's really actually the opposite of dangerous and chaotic. And like David said, you're not adding chaos, you're just measuring the chaos that's actually in your system. So I think that's one of my favorite myths that also you can debunk.
Mine is that you have to be doing the testing in production in order to be successful, which I think we know isn't true, but I have heard it that unless you're testing in production, you're not getting the true value. You're not really getting all of the insights. And I think it's true that there's no environment production-like enough to exactly mimic what's going to happen in the production environment, but that doesn't mean that every other environment is valueless. And I think if we believed that, then performance testing in non-production environments would not be happening either. We clearly see in other disciplines that testing in non-production, you still can glean some insights. So there is an iteration process that you can take. There's no reason to, just because it's chaos engineering, take it directly to production on day one. Just with like you would with anything else, you can start in a very controlled sandbox environment, move into your non-production environment, increase your maturity level with the practice, and then eventually one day, sure, work toward that higher level of maturity with chaos engineering where you are experimenting in production. But just because you're not there yet doesn't mean you aren't learning anything at all about your system through this experimentation.
that is so key. I find that's spot on what you just said. Yeah, I mean, you gotta feel comfortable with the tools, feel comfortable with the practice, right? Start familiarize yourself with what you're trying to do and what you're trying to achieve. Then the next step comes is, am I generating value in doing this? You have to remember that's kind of what you have to be focused on. Is you're breaking stuff, generating value, are not necessarily the same thing. So I love that. So I'm gonna, and also I want to add on to what Courtney said. It really drives me nuts that when people in chaos engineering say the word attacks, one, I think it's completely incorrect. But two, it's a slippery slope when you start talking to security people, because what you're doing in chaos engineering, it looks nothing like an attack. Right? There are things that really look like attacks, and that's not an attack. It's an experiment. We're experimenting. I mean, that's a fundamental tenet of all engineering. This is experimentation. So on to the next question. Since I said engineering, we have some engineering-related kind of questions. The first question is, there's a lot of chaos tools available. What are your favorite, and how do you select the tools?
I talked a little bit about this in my presentation at the GOTOpia Chaos Day as well as SRECon 2020, but I think there are a lot of different tools for chaos engineering out there, and any organization that's going to get started on a chaos journey should take a look at multiple open source libraries that exist, vendor tools if you have the budget for it. At Vanguard, we did a full evaluation, honestly hoping to leverage something open source and get it for free, then not really finding something that fit into our security controls and pivoting to maybe we can buy something, and then we didn't have the budget for it. So we had to pivot again and build an MVP and actually build the implementation from scratch. Honestly, the fault injection is the easy part. Integrating it with the any automated security controls that we have, accessing different instances to get there to inject the fault is the harder part, and that's very difficult to find in the industry. Even if you're bringing in an open source library, oftentimes you're going to need to write some sort of wrapper around it. So we did a full evaluation. I think it would be difficult to recommend any tool to an organization without understanding their landscape specifically. But in the process, I did find so many incredible open source libraries out there, and we're actually constantly re-evaluating them as well, keeping an ear to the ground on things now coming out of AWS with the fault injection simulator. New open source libraries are popping up. It feels like every single week to do this. So the fact that we have a chaos team that can constantly re-evaluate these things is very helpful.
My thing would be just remember, similar to DevOps, like DevOps isn't a tool, right? You can't just like buy a shiny thing and suddenly you're doing the DevOps. It's the same thing with chaos engineering, whether like, vanilla chaos engineering, security chaos engineering, either way, like tools are obviously important to the process. But you can't just buy like one tool to rule them all, so to speak. Like it's much more like a set of principles and practices, just like DevOps.
One of the things I guess I would add to that too, so I totally agree with what you're saying. Open source can have the same appeal that way. Engineering is a very opinionated craft in general. It's what's interesting is that try to understand the failure modes and the technologies that you're deploying and utilizing and trying to make stable, right? Because a lot of open source tools, I'm not being critical of them, but they're repeating Chaos Monkey on a different platform. And the Chaos Monkey was created as a result of Netflix seeing that exact problem, right? Like just killing a pod, killing a VM, why? Is that a problem you're seeing? Is that why you're injecting that failure? Is that just new ways of killing things and ratcheting up CPU? Is that what you're seeing? Is that a problem? Is that what you're trying to validate? So I encourage people really think about why you're doing it. And you might need to write it in Bash or Python or for an MVP, right? Because that will be more aligned to the value you seek in the end. Is kind of what I'm thinking. I should shut up. Okay. Next question. Okay. What are some strategies? I guess it's kind of part two to this. For this question is, what are some strategies for testing systems for resiliency? I guess kind of the question follows on. Is there some sort of synthetics? Is it? Do we? I guess you hinted, Christina, towards maturity model of non-prod versus prod. Does anyone have any comments on strategies to take towards doing this?
There are two different types of chaos engineering that I do at Vanguard. And so the conceptual strategies are, we're either running a chaos game day where we have a hypothesis going in where we know, okay, I think if the system failed in this particular way, this task crashed, CPU utilization increased, I should see automatic task replacement. I should see auto scaling. The system should be okay. I'm going to validate that. Oftentimes we look to either analysis we've already done of our architecture, recent resilience mechanisms that we've built in, or past incidents that we've since attempted to mitigate for what we should be validating. And the other type is a chaos fire drill, which is when we are injecting a fault that we wouldn't necessarily be automatically resilient to, but that we want to be prepared for. We want to have the appropriate observability to let us know when that happens. We're testing our alerts in that scenario. In some cases, we're testing our incident responders. I've used this as a mechanism to train new people joining an on-call rotation. So those are the conceptual strategies, either the game day where you think you're going to be okay and you validate it and maybe you're not right and it turns into a fire drill. And then the fire drill where you're actually validating incident response procedures are going to work the way that you hope they will. And then underneath, injecting the actual fault itself is going to vary depending on what kind of system you are trying to target with that failure and what you're trying to do to break it.
I'd also like to point out that I think Christina just answered Adi's question, which was, are we observing existing chaos or adding chaos? How is chaos engineering different from simply monitoring prod? And I think there's a whole aspect of chaos engineering that's not just about the internals of your technical systems. Our systems are socio-technical systems. People build them, people maintain them, people handle them when they fall down. And what's really fascinating to me is that a lot of chaos engineering experiments reveal things about your organization, not just your technology, structure or architecture or, your monitoring and production. And so you find out things about your incident response team, or, oh, wait, the security team wasn't talking to the, engineering team about these things, or how many people do we need to actually handle these things? We only have 2 people on call. I could be the list goes on. And so monitoring production, tells you what you expect or not expect in your technical system. It just is validating that those tests that you set up work. This other whole discipline and set of practices tells you if your organization is working the way you expect it to or not. And I think that's one of the sort of hidden aspects of something like chaos engineering that it surprises people probably when they get started with it.
It touches on Scott's question as well about can chaos engineering be used to find holes in the observability? And I think absolutely. I think you need the observability in place first because you have no way of seeing what's going on in the system. You're not going to be able to get anything out of the chaos experiment because you're not going to be able to see the effects. But if your hypothesis, for example, is in this scenario, I get an alert and then you inject the fault, you can see that it happened, but you didn't get the alert. There's your surfacing of the holes in your observability.
That's one of the things that I do as well, is look for those holes and then work with our internal hunt team to hand this off saying, I know we have a gap here. Has this happened anywhere else? Do we see this going because we know that it did not alert? Here's something, a good analytic that you can use for your own hunting hypothesis.
So I would add on to this, and maybe Kelly can extend it. But it's one of the coolest. So one of the biggest problems in software security is observability. It's hard. We don't have. We're very bad at it, and people in all of engineering forget that what observability is for. It's for humans. It's so humans can. It's the idea of understanding what's going on inside the computer by what it's telling you externally, right? And we just don't, especially in software security, we don't have good observability. We have so many alerts now. Every tool's got an alert now. They're sending so many things. But what I like to tell people is if that alert, if you can read it and it doesn't make sense, delete it. Get rid of it. Mute it, because it is not helping. It is making the problem more complicated. It's supposed to inform the human. There's this security tool that I saw at a conference once that said, "Give me all your log events for every system you have, and I'm going to predict your next breach or outage." I said, "Really?" That misses a fundamental tenet in engineering. Is that you're assuming you have all the right data, right? Because where do log events come from? Software engineers write them. What do software engineers prioritize? Features, not log events, right? It's we typically design log events at a state and time of a system. Anyway, it's a very interesting problem. Well, I love it how chaos engineering, and security chaos engineering are kind of highlighting that proactively when there is not a fire in the room. You say, hey, if this would have been a real incident, we did not have any idea what was going on. I find that cool.
Yeah, I think there's this very, very subtle shift that security chaos engineering involves. Traditionally, security teams, other than the really good ones, weren't necessarily prioritizing understanding the underlying systems. They were very much kind of operating in their own silo, away from kind of like product and engineering teams. So when an incident happened, they didn't necessarily understand just like how that impacts the system, like what are even the components in the system. I think it's kind of famous at this point, almost like a meme that like if you ask the CISO, like what's our like cloud footprint or container footprint, they're like, I don't know, no clue, right? I think the subtle shift here is that it's no longer really saying like, okay, we found a badness, like there's some indicator of badness. Now it's much more like the security team needs to understand like what, like how did the badness manifest? And it sounds like kind of pedantically simple, but it is different because the latter really involves understanding like in the context of the system, understanding parts of the underlying system, whereas the former one is just like, okay, like match it with some sort of indicator of compromise, which is not nearly as informative. And certainly like you're amputating your feedback loop with the former, whereas the security chaos engineering, you're being a little more curious. Kind of like to David's point, like you can go and say like, okay, where did we see something similar in other systems? And like indicators of compromise aren't going to be enough to really like do that exploration. And yes, this is part of the reason why in our ebook, we talk about how a lot of security does need to now be more decentralized and be owned more by like product and engineering teams themselves, because they do understand the system. So it sounds really subtle, but actually involves like a pretty big shift.
Definitely. So here's, I think Christina answered this question in a funny way. Nora Jones has always said this, but like, well, so what is the best practice to engage with multiple teams in a large enterprise company with multiple complex systems? I feel like you're going to say chaos engineering. Well, go ahead, or Christina, take a shot at this.
Yeah, this one is always going to be a difficult problem to solve, right? Coordination across teams ends up being more difficult than the actual fault injection itself. In my experience with the first two large-scale chaos experiments that we ran at Vanguard, we were really intentional about putting a coordinator or two or three in front of the experimentation and made sure that those coordinators also had the sway, the power that they needed to allocate resources appropriately toward the effort to ensure that it was getting the attention that it needed. So this wasn't just we, threw a couple of developers at it and had them attempt to get everyone together, because you're always going to get those teams that have a deliverable coming up and they don't have time for you and then nothing gets done. This was like we had our architecture office manager involved with me to coordinate, and then another manager for the program who had a relationship with the business, who were all working together to coordinate resources and coordinate the effort. Now that sounds like a lot of work, but not every single chaos experiment is going to happen at such a large scale. For us, the large scale chaos experiments that kind of take up an entire department or subdivision are happening more on like a twice annual, maybe quarterly basis, whereas smaller targeted chaos experimentation is happening daily.
Great. David, any comments on that one?
Not nearly as good as what's already been said.
I know. She nailed it. I'm gonna open this up to, I guess. So the question is, and I'm gonna broaden the question. Is from Kevin. Thank you, Kevin, for all the great questions. When creating a chaos engineering team, what skill sets or experiences do you look for? So I'm gonna back up here. What I'm gonna say is, back to the program question. Back to the getting started, right? Like, so what are the models for this? So is it, do you do game days on an existing engineering team? Do you do SREs run tools? Who does the chaos? Does it have? Are there multiple ways it could be done in an organization? I'd love to hear different opinions and like how this works, but also touch on Kevin's question of like also what kind of experiences and skills that team or people on that team would need.
I know I was there for the beginning of the formation of our chaos engineering team at Vanguard, and the answer here will really depend on the scope of the team that you're trying to form. So you can do chaos engineering for a product without having a chaos engineering team, right? You can just have even one engineer within a team who's really passionate about this, who figures out how to do it, writes their own library, leverages an open source tool, injects the faults, and does it on a really local level. You could have it for a department, or in Vanguard's case, we have a chaos engineering team for the entire enterprise. So the skill set we need on that team is not necessarily going to be on that localized level, figuring out exactly which experiments to run. It's going to be enablement of the injection of faults for all of the different types of platforms. And our scope in particular, to start us out, was let's look at the cloud platforms. So we brought in people to that team who had experience with cloud infrastructure automation. And we also brought in really strong Python developers. Doesn't have to be Python. You can pick your flavor. You can do this in just about any language. But we had Python developers. We had cloud infrastructure automation experts. And then we also had people who had a little bit of background in site reliability engineering concepts and were just really passionate about the subject. Most of the skills were learned on the job on the chaos engineering team, and some of our most effective members of that team have been our intern, our junior developer. This is not something that you need to suddenly collect all of the best architects you have at your organization. You can teach these skills to your junior devs as well, and they've been incredibly effective on my team.
Yeah, I think I get this question quite a bit on the security side. And I feel like people are hoping for some just like magical set of skills that's going to make everything like amazing. But it really, like, it's going to be mostly bootstrapped. It's a new discipline. Like, you're mostly going to be learning on the job, like really the skills needed. It's more of just like having someone on hand who like can code, someone who understands systems, like someone who can kind of like diagnose things. It's pretty straightforward. And that's even true on the security side. Like, one element is you need to be able to kind of understand just like what kind of like unwanted behavior you do expect and how you expect your system to respond to that. But like, that's just one security person who maybe has some sort of kind of like threat modeling or offense background, right? Like, it really isn't too difficult to get started. Again, it kind of goes back to the original discussion, like chaos engineering. I think mostly my hot take is like mostly because people are angling to like make money or make it seem really difficult in order to like preserve their own kind of like position. It's really not. Like, you can like use interns, like why not, right? So I would definitely caution anyone who sees job recs where it's like 5 years of chaos engineering experience. Like, no, you don't need that.
I just wanted to chime in and say that I think the non-technical aspects, you're going to get sick of me saying this, people, but the non-technical aspects are really important. I mean, the things that Christina and Kyle are talking about, people who are like curious, passionate about that. Like, you're not going to convince someone who doesn't want to do chaos engineering to suddenly just like go do chaos engineering. The people who are curious, who think experimentation is, a really important approach to understanding things, you can teach people Python or whatever language. Like, talented developers can learn whatever language they want, but they can't learn to, be humble and be curious as easily. So those are the characteristics that I would prioritize beyond, I think, the obvious things that Christina has already sort of mentioned in terms of the at least core technical kinds of needs of something like that.
Yeah, I echo all three. The hardest one is just finding someone who wants to just look at data. We could get red teamers all day, but red team doesn't want to do that kind of work. They want to keep doing new innovative things. They don't want to, I'm going to say QA, even though nobody likes QA. They should, because it's QA. Is the work you're doing doesn't work. So it's effectively the same thing for me.
I was just going to say, you brought up a great point, and Kelly knows where I'm going. Is that like, one of the things that kind of is, through my journey with security chaos engineering, people always confuse it with red teaming, purple teaming, breach and attack simulation. And, I don't know why, I've been part of this, I've been around in engineering this whole last 20 or so years. Like, I don't know why, security is treated like this other thing, and then like the system is this other thing. It's like they're not part of each other. which makes no sense. But like, you know, a lot of people in security not in security, have these weird concepts of what they think red teaming and pen testing are, and purple teaming is usually not. It's something that's sort of widely known, but like purple teaming was supposed to be an evolution of red teaming, from red teaming being kind of like the DevOps wall, where like the red team would penetrate, do pen testing, and then they would try to attack it. They would get in, they would send a PDF report, throw it over the wall to the blue team. Blue team, okay, what am I going to do with this, right? Like, but there, I'd like Kelly and David, if you want to dispel some of those myths, kind of what we're doing around sort of, I kind of like to call security failure injection or fault injection, because I think that's a clear distinction, but go ahead. Sorry, I'll shut up.
Yeah, so I mean, there are a few problems here. One is that most people get red teaming wrong. They think it's just like, haha, we showed those blue team. Like, look at how dumb their like security program is. Like, that's wrong. I like how Toby Kohlenberg talks about it as like, really, it's a form of alternative analysis and playing like devil's advocate. And when you view it through that lens, like red teaming done right isn't that different kind of conceptually or philosophically than a lot of security chaos engineering. The problem is like no one does red team kind of right in that sense. And the other thing is with red teaming or like attack simulation is you're kind of like doing end to end, whereas security chaos engineering is very much again like those like very like specific experiments. You're testing like a specific hypothesis. You know, if you're like really wedded to like the kill chain model, it's like you're looking at just like one slice of the kill chain model. You're making sure that you have like the alerting and stuff. I think red team is, I think for now it's complementary to security chaos engineering. I will be curious in the future whether it's necessarily is showing the same sort of outcomes that security chaos engineering does. It's certainly cool. I'll give them that, right?
I will say that the terms for red teaming has changed throughout the last decade. When it used to be pen testing, then it became red teaming. Vulnerability manager, vuln assessment, pen testing. Then those ones started getting poisoned by everyone saying, I'm a pen tester, when you're running Nessus and scanning and handing over results for like $10,000. Then we get to red teaming. Well, now it's being swamped with red team everywhere. So it's sort of pivoting to adversarial simulation. It all means the same thing. And now we've got purple team. I see a lot of overlap with security chaos engineering and purple team, specifically looking at the detection coverage, looking at what attacks are going in there, going against MITRE, seeing what our coverage and heat mapping looks like. So what I propose is that it's like, well, we're taking a step back. We're not focusing on detection. We're looking for the performance of the tooling itself as it exists in real life, not really detecting adversaries is the concern. It's looking for the observability and measurement. If it detects, cool. If it doesn't, cool. At least we know where our baseline stands and we can start improving from that point on.
Totally agree. So I would also echo. I don't think anyone here is saying these practices are bad, right? Like the security people here are just, we're very we want to see our craft improve, and like purple teaming. I once had a conversation at the IANS Forum Summit in Washington, D.C. with the chair on purple teaming. And I just had I was asking him so many questions from the audience. I was like, he's like, you want to get up here? And I'm like, well, it's like, he's like, well, Aaron, he's like, have you ever thought about how security chaos engineering could actually make purple team better instead of being how it's different? Right, and that's kind of how I like to look at things. Is how is this addition, this new sort of technique, can extend and improve our ability to make these other crowds better. And that's a good way of thinking about it as well. So we have a couple questions, a couple minutes left. I would like to, I would like to ask one more question. Of everybody, I'd like to go around, everybody individually, but what if you could leave an impression on anybody here really wanting to learn about chaos engineering, whether it's something they desire to improve their skill sets, whether it be they want to implement their company, what is one hot take, pro tip, or one, leave behind that you can empower them, to make a difference?
Well, I mean, I'm going to be obnoxious and be like, read our report, right? Like, I have to give a shout out to that. But more seriously, I would say on the security side, like, look at that. It's beautiful. It's beautiful. It's so beautiful. On the security side, like, start with the low hanging fruit. Don't try to do the like Mossad has hacked the chip in your toothbrush sort of like chaos experiment, right? Like, that's not a realistic threat model. Start with just like, there's a misconfigured port in like the chaos slinger case. Like, start with stuff that's like very much in your threat model of like, what's the like dumb or seemingly dumb stuff like an attacker is going to do first, not the super, super advanced, like fancy, sophisticated threat actor sort of things, right? So that's my hot take for a tip.
My hot take is use attack trees to help guide people to have a bit more visual understanding so you know where you can go in there. I spent way too much time making attack trees, but I love attack trees. And like Kelly said, start small. Start with something that people can feel good about, because if people feel like you're attacking them or they feel bad, they're going to dig in and stop you from doing things.
Oh my gosh, that's such an important thing we didn't bring up. Like, we're advocates. We're not punishing people for things. That's great.
So I think the major takeaway that I hope everyone has is that doing chaos engineering alone won't be enough to suddenly make your system more resilient. Chaos engineering is the validation mechanism for the expectations that you have about the way that your system operates, and it's going to surface any discrepancies between those expectations and the actual reality, but that's just the first step. And after that, you should take those results from chaos engineering and do something about it. If it didn't match the expectations, figure out why. If you aren't satisfied with the results, build something into the system to make it better, whether that's the technical system or the incident response processes that you have in place.
Yeah, I mean, I think everybody has said the things that I would probably say, but I would just go back to thinking about this as a form of experimentation. And so if you didn't get all the science classes, do a little homework, go back and look at, really, I think one of the hard things, and people have been saying this, is like, what is your hypothesis? And getting a really good hypothesis is not easy. And so spending some time thinking about that and what that would look like and what you would expect. I mean, really sort of go back to the basics of experimental methodology, if you're not as familiar with that, and sort of strip away all of the technical pieces of it for a little bit, and really understand how you feel like you could create something that's a really high quality hypothesis. And so that would be my suggestion.
Great words of wisdom. And I just want to take the time to thank everyone that was a panelist here. I really think this is this is a great first for security chaos engineering as a panel. And I really enjoyed this panel. And I want to thank you all for also attending.